We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello students, so today we will discuss about the separation problems. The problems like band tailing and peak distortion. And here are some contents out of the. They will discuss one by one. So this is the ideal ideal chromatograph like a Gaussian shape. Whenever the operator is operating that instrument like LC systems or HPLC, these are the problems most widely occurred. Non-Gaussian band shapes. This include the moderate tailing, severe tailing, fronting, peak splitting, fat peak. There are several reasons out of that. I am sliding this slide because the reader can understand this why it is happening. This is another chromatogram like in that absence of bend tailing for good chromatography. How to solve the problem of tailing or distorted bands? The possible cause, identify the possible cause. So pattern, consider the nature and or pattern of peak distortion. Are some or all peak tailing? Does be a tailing change in regular fashions like here asymmetric factor is also changed. If it is 1.2, then it is fairly acceptable, but asymmetric factor is 2.0, that is not acceptable. If it is 4, then it is condition, full condition. To understand the chemistry related to the general chemistry of preparation, separation to the specific possible cause, try fixes, various specific fixes is described below. Is it logical? When you have arrived at a solution to the problem, ask yourself if everything about the problem and feature makes sense. Only then proceed with the separation. So these are the different contributions like bad column, sample overload, wrong solvent. These are the possible causes. Bad column, block, fit or void. This is the main cause for that. These are the another chromatogram, tailing and peak splitting is also good. So general approaches that we can solve the problem like reverse and flush. That is the best possible solution. Flushing of the system and reversing of the column. That is the main thing we can do. Replace the frit. If column reversal does not solve the problem, then remove the column from the system and carefully open the original inlet end of the column and remove the frit. Examine the packing for any settling or void. If column packing is smooth and level up and insert a new frit. That is again discardation. Sample overload may be the another cause. These are the some another chromatograms which replace that. And wrong solvent for sample. For that, this is a chromatogram that injection of sample are too large, volume too strong. These are the another chromatograms. Sample solvent that is too strong for A, B, same. These are the representation. So causing what are the causing problems and try one of the alternatives over here. Try to one is reject a smaller volume, Re-inject a smaller volume, means 5 to 10 microliter of the, and look for the changes that is happening or not. Ideal, the best option is to dissolve the solvent in mobile phase. That is the ideal solution for them. What will be the practical alternative? A larger volume of weaker solvent can be injected, 100 to 500 microliter of sample dissolved in water for the case of reverse phase. The main disadvantage is the larger volume baseline upset at the beginning of the chromatogram in some cases. Larger volumes of a sample dissolved in mobile phase are also okay, except that resolution may suffer for only eluting bands and or smaller volume columns. When necessary, when convenient or required, 10 to 25 microliter of the stronger solvent can be injected. 25 microliter of the methanol solution or for reverse phase. Dilute with sample with a weaker solvent. For the preceding example of 30, and these are the weaker solvent, 20% methanol water. These are the another chromatogram illustrate the band tailing by extra column band bonding effect. Extra column effect was there. These are the explanation. These are the another chromatogram peak fronting is observed in European chromatography. So band fronting, these are the possible causes for that. So stronger retention sites is also there in the column packing. These are the another chromatograms. Elimination of tailing in the late eluting bands by isograding. So by using the grading illusion, we can improve the separation. The graph like B. Secondary retention effects, reverse phase LC. So in that, these are the several chromatograms representing the secondary retention effects. So these are the possible reactions in ionogen. These are the for the secondary retention. Even these are the reaction involved in that. So whenever band tailing caused by secondary retention is observed, the addition of modifiers of related structure to the mobile phase usually will result in the reduction of band tailing. Samples that contain acidic or basic compounds present the special problem. This is seen where addition of acetate to the mobile phase improves the. So these are the modifiers we can improve their separation. These are the explanations. These are the possible column and the possible amine modifier, which is responsible for improvement in the chromatography. These are the compounds. ODS octadecylsilane hypersil column. In that octadecylsilane is sealed with the base treatment, or trimethylsilane is used for end capping. Base deactivated silica is also used, and we can move further. These are the acidic and basic compounds, and that effect on that is very crucial. Reaction effect is also observed. These are the chromatograms, secondary retention. For the secondary retention, trace metals, which is also in the reverse phase packing, are also observed that the heavy metals like iron, copper, etc. They give rise to the secondary retention. Heavy metal contamination of the column packing. These are the possible chromatogram. Normal phase for that, these are the chromatogram for that. In that secondary retention, like chromatogram like SCC separation, gel filtration, size exclusion chromatography, ion exchange. These are the mechanism involved in that. Ion exchange, hydrophobic, ion pair chromatography. Ion pair reagents can be used to enhance the resolution and possible chromatography. Diagnosing secondary retention problem. These are the another chromatogram. Inadequate buffering. These are maybe possible causes there. These are the another chromatogram, tailing of bands. Miscellaneous and other effects. These are the other effects and possible causes for that. These are the diagrams. Pseudo tailing is also observed in the chromatography. These are the possible uh, chromatograms for them. These are the another chromatograms. The possible causes. So this is the overall summary of band tailing problems and solution. In that bad column, possible symptom solution, sample overload. These are the all possible causes. Secondary retention effect. These are the possible causes in normal phase, reverse phase. Solution also represented over here. Another separation problems, other changes in the appearance of the chromatogram. These are the contents. And starting from the wide beds, small n values, there is a theoretical period. Column deterioration, possible causes are column deterioration with use, extra column, band bonding, chemistry effects. These are the chromatograms over here. Excess band bonding is observed over here. So articulated peaks, these are the chromatogram, the negative peaks are observed over here. These are the articular peaks example. The simple feature of ghost peak and vacancy peaks are also is there. Some example of ghost peak and these are the explanation for that. The model of Stanhan and Demning. These are the model possible causes of model. The computer simulation of articular peaks, CTX. This is the cooperative and competitive like of peak is there. These are the equation for that. These are the textbook explanation. Remedies for articular. What are the remedies about impure mobile phase reagents and use of mobile phase is a sample solvent. Inject a minimum volume of a sample solution. Retreat the sample. These are the reaction of sample. This is another type of important cause for that. This is relatively uncommon. Retention prior to injection, reaction during separation, reaction in gradient dilution. These are the possible causes is there. These are some typical chromatograms. You can see over here that bad chromatography is observed. Different temperature because of the sample reaction. Reaction prior to injection, these are the tags. Reaction during separation, these are the tags. These are the another chromatograms. Revealing that the column has changed like octasilica and octadecylsilane. Here the reaction is different for the sample and the graph is changed. These are the another chromatograms. These are the few other chromatograms. Here the sample flow rate change. So during the separation this happen. Sample reaction change. Reaction in gradient dilution. So what happened at that? These are the chromatogram in represent the reaction of protein during varying retention time. So how the variation in the retention time happen? Column to column, day to day, within day, sample to sample. Poor control of separation conditions, slow equilibration of column, deactivation of column overload in sample matrix, interaction effect, variation in separation condition. These are the possible changes when we take place and how the influence on that on retention time. If we change the flow rate 1%, then possible cost for on the retention may be minus 1%. So 1% of mobile phase can be changed or may be changed. Not can be changed but may be changed. Mobile phase composition, if we change that, these are the possible variation. And another hypothetical change in retention time as a result of change in flow rate. If we change the flow rate, how the ratio change and how the retention time change is also there. Wherein the mobile phase composition is also there. Slow equilibration of the column. This is important because column equilibration is required for the adequate separation. So this is a table that approximate wide volumes of the various columns in a usual volumes of mobile phase required for equilibration. Ion pairing reagent is also used for enhancing that, like quaternary ammonium ion pairing and tetrabutyl ammonium. Silica columns, tetrahydrofuran as a solvent you can use. Deactivation of columns, sorption of chemical garbage. Now these are the cleaning columns that have been contaminated with strongly. This is the possible washing medium we can use most of the organic solvent. Column overload or matrix effect, varying band spacing. These are the few another chromatograms. So lastly, we have to summarize all the things that cause of the problem, symptom, and the solution. Bands are observed due to that column deterioration of the use. We have to flush the system with a strong solvent, replace the column, use the guard column or better sample preparation to extend the column life. These are the possible causes and solution. These are the references. Thank you. This is the end of the lecture.